Good morning. Hello, everybody. Welcome to the February 9th, 2018 UK edition of the Intuit Developer Crossed Off Morning Hangout. It's morning for me. It's super early, but it should be noon for all of you in the UK region. I'm your host, David Leary. I'm the Global Small Business Ecosystem Evangelist. You can follow me on Twitter at David Leary. Today we have a special guest from Estimote. Marcin is going to be here. He's a senior software engineer. He's going to tell us all about the Estimote devices and how you're going to be able to use those at the upcoming hackathon that we have in London. Just a couple of announcements before we get fully going here this morning. Again, for the third year in a row, we are going to do the $100,000 Small Business App Showdown. So you have 187 days to get your app finished, published on apps.com, and to join the contest. And what we'll do is everybody who joins the contest, there's a range of criteria we use to judge the app. Some of it's a public voting phase. Some of it's the connections you have. Some of it's your reviews. Then we take all that criteria. We come down to the 10 finalists. Then we take the 10 finalists all the way to San Jose, California for the QuickBooks Connect. You pitch in front of the audience and judges, and the winner takes home $100,000. So it's a really big contest. It's exciting. It goes year round. And then this year we're actually doing some things after the fact and doing really promoting all 10 finalists for really the 6 months following. So it's a really good way to help newer developers get some traction with their app and get introduced to the marketplace. So you want to go to smallbusinessappshowdown.com to join that. Some other announcements. We have, I just talked about our big conference, QuickBooksConnect.com in San Jose. I know many of you watching this are in London. Please take a plane flight over. It's well worth your time. It's one of the biggest conferences related to small business or accounting in the world. So put this on your calendar. Think about showing up in San Jose in November. But we're going to come see you. So about 2 weeks, I think we're down to 2 weeks, about 18 days, 19 days. We're going to go to London. We're bringing QuickBooks Connect to London again. This will be our second year in a row doing that. We'll have sessions for accountants, sessions for small businesses, sessions for developers. Coincidentally, when I went and grabbed the screenshot of the website, these three guys here, they are developers. They came to the hackathon last year. They won the hackathon last year, and they actually have their app. It's going to be on apps.com anytime now. So you could be a developer just like them who creates an app at the hackathon, wins the hackathon, and then you get to publish on apps.com, and eventually you get on the front page of the QuickBooks Connect website. So they're like mini celebrities a little bit. Their app's called Arbitrue, and I think their whole team is based out of Poland. So, and then just as I mentioned, we have our hackathon. So we are doing our hackathon in London. So we're doing that on the 24th and 25th of February. You can go to smallbizhacklondon.com and get signed up and register. It is free to register. There is a limited number of seats. So if you haven't registered yet, don't wait till the last day. Register now, and hopefully we'll see you there. You can win £5,000. And it's a pretty straightforward hackathon. We're going to, you just have to build something that solves a small business problem. And then we have some of our great partners, for example, Estimote, who's here today. So, and then just one more announcement. Like this event and all our other events can always be found on the events page, developer.intuit.com/hub/events, and you can register for any of the Hangouts. So just a couple of notes for you guys in the UK. Obviously, today's Estimote, they're here. Next week, we have Clarify AI. The week after that, it's going to be a QuickBooks, which is another partner of the hackathon, and then the actual hackathon itself, which is taking place in London. So you want to go to the events page, you get registered on some of these events, and so the way they show up on your calendar. Without further ado here, I'm going to change screens and stop sharing. And hopefully Marcin's video is working. I see your face. Good morning, Marcin. You're on mute. I'm going to have to unmute.
Yeah. Okay. Hello, guys. Nice to see you. I'm Marcin. Okay. So can I start, David?
If you want to jump right in, good morning. It's not morning for you, though. It's
It's actually middle of the day here in Poland. So yeah, it's really exciting actually to see you all here. I'm after the second coffee, so
okay.
I'm more caffeinated than probably you. Yeah, but anyway, I hope you will enjoy the entire presentation. We'll try to cover some basic concepts, first behind the company and things we do. And then I will also try to cover the basic technology we provide. Also at the end, diving a bit deeper into some of the regions that you may be interested in. And hopefully you will use at Hackathon actually to build the software I hope it will be exciting for you. Definitely, there is a lot of going on behind the smart office and smart spaces right now. And we are delivering a lot of nice technology that can be used for these kind of spaces. So definitely small business can benefit.
Oh, that's exciting. So while you, I know you have a little bit of presentation, then you're going to do some demos, and then we'll do some Q&A with the attendees. If you would, while you're starting to share, I'm just going to make one more announcement to everybody. As a reminder, everybody, use the Q&A panel to ask questions along the way that are on topic. And then everything else, like I can't hear audio or anything like that, any chat-related stuff, just use the chat panel for that. It just helps things, makes it a little bit easier on me monitoring and getting these questions out to Marcin. So Marcin, feel free to jump in and share your deck.
Okay.
Looking forward to hearing.
Sure, thank you. So yeah, let me share the screen first. Okay, so hopefully you can see my screen right now.
Yep, you're good.
As I mentioned, we'll start with the simple deck. So we'll just go through some of the basic concepts. Because I don't know exactly if you are all guys familiar with the technology and the concepts that Estimote is trying to achieve. I will start with some basics at the very beginning, just explaining what we do and what kind of technologies we try to build. From the very, very beginning, Estimote was promoting itself as a company that is building operating system for physical world. And that's definitely something we do. The one important thing that you can get from that sentence is that we are purely software company. Of course, we build hardware, and that's also quite important part of our daily operations. But definitely at our core, we are a software company, and we've been focusing very, very strongly on building software. Of course, hardware, that's something that you should strongly consider when you are building software. And as Alan Key some time ago said, people who are really serious about software, they should make their own hardware. And in the space of beacons and actually distributed computing, that's definitely a thing. And maybe I will just try to quickly explain why do we actually mention this operating system for physical world.
Did you, can you repeat who, that's a quote from who?
Alan Key.
Alan Key, okay, that's a really interesting one. I haven't heard that before.
Great, you like it. Yeah, so if you think about the history of computing, looking at the way computers developed, starting from the terminal-based machines, going to the actual graphic-based UI, that's exactly something we are trying to do at Estimote. Just take take those interactions that we have in the physical world and try to build the canvas that will first replicate, so visualize that physical world. And then based on that virtual canvas, we want to let our clients, developers, to build some kind of third-party interactions. So very, very basic analogy. I remember that from the very, very beginning when I firstly met the founders of the company. They've been explaining the entire concept of the operating system that is behind Estimote as just building a virtual desktop where you have some windows, some regions of the screen that you can just press or hold, interact in general with them. And that's exactly something we want to do with the visual world. So if you think about, let's say, the office, we want to make that office as a screen where you can define some kind of interactive regions. You can mark some areas like conference rooms. You can then tap that conference room. You can see what's there, what kind of actions you can perform. But it's also very much more interactive than the basic computer implementation, because in here we are using the mobile phones and mobile devices. So you can think of trying to convert cursor that you have on your desktop to actual people. So you are together with the phone, you are the cursor that is navigating that desktop, that virtual canvas, going to different regions and interacting with those regions in completely new ways. that are actually from one side completely transparent for you. So you get that information only when you need it. I need to mute.
It's okay.
Yeah, so that's something that we definitely try to achieve. But of course, that's quite complex problem. We need actually completely new hardware platform. That's why we are strongly working on the hardware. Because with computer, you have just one machine with processor, with the screen. In our setup, we have actually distributed computing power in the beacons, so around the spaces, so just small computers. Then we have the entire cloud computing part as well that is supporting those smaller machines. So it's much more complex ecosystem that we actually need to achieve. That's why it was actually impossible for us to just focus purely on software. We had to have our own hardware. And also, because I work here for the last 5 years, I can definitely say that the quote that I mentioned is absolutely true. And honestly, I think 3/4 of our achievements were possible only because we were able to actually put some stuff, some kind of implementation parts on the beacons and the other on the mobile phones and in the cloud. So it wasn't impossible to actually build just a mobile software or cloud software. You just need to have full control over the stack to build this kind of solutions. Last year, actually, we've been also partnering with the Hackathon, and we've been mainly covering the proximity cases. And that's something that was at the very, very beginning, very hot topic. When iBeacon was introduced, then Eddystone, like 2 years after, those were packets that were driven by big companies like Apple and Google. And they've been intended to be used as some kind of protocol responsible for delivering contextual informations inside spaces. And that's something we covered last year, as I mentioned, and we've been trying to focus mainly on that. But during the last year, a lot of things changed. Our stack also evolved, market evolved strongly. And right now, we are a bit more focusing on building something we call location intelligence. So with that concept, we're actually going through that proximity, things like proximity marketing, some proximity-based content engines that we've been working with mainly in the past. And just a quick note here, you shouldn't think about Estimote as a company that is delivering the end products to the clients. We are building the platform. So we are building all the tools and technologies that are required by the third-party companies to actually build the products for clients. So we are not interested, we are not even trying to compete with them. We are just trying to partner with them and deliver the best possible software possible. So they can focus on their business, and they don't need to bother about the technology that is, from my experience, extremely difficult piece of that entire machine. Location intelligence is actually making our spaces and the rooms, the halls that we spend most of the time, actually, based on some reports, even 90% of our lives are indoors. We try to make those spaces much smarter. So first of all, there are few crucial things we need to have in place to actually virtualize those spaces. And by making them intelligent, we mean first of all, giving you an understanding what's happening in that space. Of course, we have some basic senses, like, we can hear things, we can see things, but definitely we want to take that to the next level. Like you can think about additional sense we are trying to add here. Just giving you very, very contextual information and complete information about the entire space you are in. Of course, there may be some events happening in the space that you cannot see because it's too big, or you cannot hear because it's too loud. But with our platform, we see we actually want to deliver some additional piece of information and make some decisions just simpler in that spaces. But to get there, actually, we need to have few different things in place. The first thing is actually making that space available in the virtual version. So if you think about an office, for example, we need to have structure of that office somewhere virtualized. Most companies on the market are trying to just do the most basic thing. So just take a floor plan and then like build on top of that. So you just need to draw all the lines, all the walls, all the objects in the space. And then like at the end of that, something like a wizard process, you have the virtual representation of the office. We are trying to innovate here a lot. And originally starting with Bluetooth technology that was actually behind the iBeacon and the distance packets. Last year, we decided to add additional technology to our hardware that is called ultra-wideband, UWB. And that's the technology that is solving a lot of problems and actually a lot of concerns that were originally behind Bluetooth. People were thinking in terms of the iBeacon packet and some proximity content. People were always trying to use that technology to calculate distance between objects. So distance, for example, between the beacon and the phone. And for this, unfortunately, we did a lot actually to innovate here, and we have a lot of software that is helping to stabilize, the distance calculations, and even we came up with our own mathematics behind that to actually calculate and filter the signal properly. But definitely, the Bluetooth is not the perfect technology for this because of its physics and the way it works. It may be very easily, the signal from Bluetooth may be very easily absorbed by objects, especially containing a lot of water, like people, for example. And also, it may be very easily reflected. That actually makes those readings a bit inaccurate. So in general, when you think about the Bluetooth, you will find information that it provides precision around 3 to 5 meters actually in the space. So sometimes it's not enough. Definitely for building that virtual representation for the office and drawing those walls automatically, it's not enough. That's why we introduced ultra-wideband. That's also the radio technology that is even working partly of the same frequency as Bluetooth, but the way it works completely changes the way the accuracy is perceived. And with UWB, actually, you can get up to 10 centimeters of precision in terms of calculating distance between two physical objects marked with beacons. And also, a very important parameter of that technology is that it's actually much less reflected and absorbed by the object. So it's much easier actually to, for example, perform the distance calculation in more crowded spaces. I need to mention that the technology is quite fresh, and actually we're one of the first companies using that technology publicly. So there is, of course, one chip manufacturer that is actually providing the hardware for this. We had to integrate that and then implement the entire software stack on top to make it usable. But definitely, it's really amazing technology, and we deeply believe that's the future of the radio technologies in terms of distance calculation. It's very precise, it's very stable, and it gives amazing results. And that's something that we definitely use for calculating the size and the shape of the space. So in very simple words, automapping works in the way that you just put set of beacons on the walls of your office, and then you just perform the quick action where actually those beacons talk to each other, trying to figure out, as you can see on the screen, they're just trying to figure out the distances between them, and then they create a shape at the end. So that's something that right now is publicly available. You can play with it using our indoor location application. You can go through the process, buying the dev kit. So then you can see how it works. And of course, right now we've been like playing with different deployment sizes, the dev kit actually is intended to be used with the smaller spaces. So in general, we address, like you can see on the picture, mainly for beacon-based spaces like squares or rectangles. But of course, it's also possible to do the much bigger scale deployment. Of course, then you can just need to buy more beacons and use a bit other services that we actually use in the app. So we have separate implementation in the cloud that allows you to just perform all the algorithmic parts and just do the automating yourself. So that's the first thing, creating the virtual representation of the location. Then we, of course, all are people, so we need to locate ourselves in the space. And that's something, the technology that we are working on for the last 5 years as well. So it was like the project was kicked off very, very early at Estimote. And we've been doing a lot of different research and implementations of algorithms, filterings, and another like parts of the math to make navigation inside the spaces easy and precise. And that's something that we promote as Interlocation SDK. So that's a piece of software, the library that you can just use. It's available on GitHub.
So is this so this is for the people tracking, if you want to call it that. And so is this I keep an Estimote device in my pocket, or am I running an app on my phone, or are you guys just doing this based on measuring the physical environment?
Yeah, exactly. So we need to first like show the environment that you are in, and then based on your application that is running on your phone, we're just giving you your exact position in the office. And we have accuracy about 2-3 meters, so it's a bit better than the basic Bluetooth precision that is available in the market because of all that math that we did and we do actually in the background. So yeah, so that's something that is also centralized. So you can collect that position data in the central point in the cloud and then share it with your friends. So then you can see, as on the picture, who is where at any given point in time. Of course, you can also check your like history, so how like even replay your session if you want. Yeah, so that's definitely something that we need to have in place to actually give you understanding where you are and also where your colleagues are. And that's the part actually of the asset/people tracking that software that we built. So in here, you just use the SDK. It's available on both iOS and Android. You just simply initialize that. I will, I think, even show that in a second, the code, how easy it is. And then you just see the positions. You can just consume it from the cloud API and display on the screen. You can use it with Google Maps. You can use it with any actual framework or UI you even implement yourself. So that's something that just returns XY position of people. And the last piece that we started addressing last year is asset tracking. So not thinking directly about people, more thinking about objects, because we perceive like location intelligence and location in general not only as a space, so just the walls, floor, and ceiling, but considering all people and objects that are located inside that venue. So that's very important to actually get like the combined information about everything that is happening inside that space. Not only see the space itself because it does not deliver any particular value, but having the combined knowledge about everything that is happening inside a space is much more interesting set of information that you can actually utilize when building some custom projects for particular niche or market. And asset tracking, as I mentioned, is quite a recent effort. You will be actually able to play with it on the hackathon. So we will bring with us some dev kits. That's the brand new dev kits that were not announced yet. So there will be like a first appearance of those devices on the market. So
you'll premiere. That's amazing. Good.
Yeah. So we will be actually able to just see how UWB, because that's something that is UWB based, how it works, how the distance calculation looks like, and you will be also able to combine that with Interlocation just to build some kind of amazing projects. For that, today we will try to do a bit deeper dive into the basic mechanics behind the asset/people tracking, because actually we are building the custom backend system for that. So we've been having for a very long time just a cloud Estimote.com. That's the dashboard that mainly is responsible for configuring your devices and just keeping track of their battery levels and so on. So it's more like a management part of the entire deployment. But last year we actually decided that we need to have a separate system that is dedicated to managing that location intelligence. It's responsible for aggregating all the information and then at some point giving you even some smarter insights that you need. Right now we have the first version of that. It's available publicly, so after the webinar you can see and you can play with it. There is a complete set of documentation at this point. So at this point we expose only API. There is no UI. I will show a very basic demo that we just prepared to show how it works. But definitely that's the API that you can just use to send the actual positions of an object, and then in relation to the location you can consume it and display it. I think on Hackathon we will be even able to distribute some custom code pieces that will, for example, let you integrate with Google Maps and just show the exact position on the actual Google map. So I hope it will be quite interesting for you. That's this piece of the code that actually you need. So that's very simple thing, as you can see. And honestly, at our core, we try to simplify things as much as possible. So from indoor location perspective, that's the code that is used on the mobile devices. So when you are building your custom application or on iOS or Android platform, the only thing you need to do actually to start tracking your position and collecting it in the cloud is just invoke more or less this line of code plus maybe maybe a few more lines of some utility stuff you want to have. What it gives you actually, it starts updating your position based on the infrastructure that is deployed in the space. So of course, still very first step, as I mentioned before, is building that virtual representation of the location. And then when all the beacons are in place and we have the shape of the location, you can start this application that is having those lines of code, and then you can just start walking around the office or the space you just deployed, and you can see your physical location updates live in the cloud. So as you can see, apart from just simple initialization and providing some credentials, the only thing we need to do is we need to just initialize the location updates and send them to the cloud. And then they are immediately available through our API, cloud API. And you can very easily consume that using both REST API, and also we provide the WebSocket API. So you don't need to ping our cloud all the time. You can just get the events when they are actually happening. I prepared a very simple example. So maybe we can right now go out from the presentation, and we can play with the API, so you can get a better understanding how simple it is and what we actually have here, what you can play with on the hackathon. So as you can see, that's the full documentation that we exposed. It's prepared based
Marcin, before you jump into the API Explorer and kind of getting into the little bit more of the code, there's two questions that have came in this morning. So one question is, why can't we just program the GATT attribute ID for each of these devices? Even when they are moved, the parameter remained the same.
Mm-hmm.
And then the second question is a little simpler. It's just, do you have a Cordova SDK API?
Yeah, so answering the second question, at this point, we do not have any publicly available Estimote Cordova support. We are strongly considering that, as we have a lot of feedback that people are trying to use it. So together with Unity and Xamarin, actually, that's the platform that we are strongly thinking about covering. But at this point, actually, we do not provide any dedicated libraries. On the other hand, as I mentioned, we are actually trying to move out from from heavy use of SDKs. So the API of the SDK is very simple, and it's just, as you saw, like 1-2 methods that you actually need to invoke. And the rest is available through the Cloud API. So I think, at that point where we do that shift, it should be much simpler also even to do some custom implementation if that's required, even before we actually address that issue. But coming back to the
Oh no. We kind of froze up. I think we're back.
Okay.
Yeah. Yeah.
Okay.
So going back to that issue about the attributes.
Okay.
I can repeat the question just so that way everybody, in case we lost anything. So the question was, why can't we just program the GATT attribute ID for each of these devices, even when they are moved, the parameter remain the same?
But then when you implement that identifier, of course we can track it, but there is the entire set of technology that actually needs to be, I think there's more question about the precision, I would say. Because as far as I understand, I'm not, maybe you can like evaluate a bit more on the question. Just providing a simple identifier gives you in general understanding if something of the presence. So if something is inside a space or not, right? But in here, we are actually trying to address much more complex problem where we actually want to exactly know where the device is. So know the exact XY position of object or person. And then the simple, just, of course, we also use some IDs actually that are broadcasted over the air. But to actually accomplish the XY position, or of person or an object, we actually need to add some additional, computations, do some kind of trilateration and some other algorithms that we actually use to provide the exact XY position.
Got it.
Answer the question. Not sure. Hopefully, I get it right.
What we can do is at the end, after you finish, we can actually promote some of the attendees that want to ask questions live. We could allow them to talk using their microphone, video, and we have a discussion if you want a little bit on that.
Of course, that would be very helpful. Okay, so coming back to the example. So as you can see, in here we have a documentation. You can navigate and actually open that website on your machine. And then we have a set of endpoints addressing different needs. So the first section that I want deeply dive into right now is the real-time part. So that's actually the part that is responsible for delivering you the socket implementation. So you can just easily, following the steps mentioned here, you can just quickly set up the connection with our cloud server that will provide you events each time something happens. So some kind of device change the position, or person change the position, you'll just get the immediate identification. And the huge benefit of using the WebSocket implementation is that you don't need to constantly request our cloud by asking about the position. You are notified only when the change of the position actually happens. As you will see later, at this point, we mainly focus on the position because from our perspective, that's the most complex problem that needs to be addressed. But of course, in the future, we will also address other attributes of the objects and people that are changing in time. So we will be able to get a notification also when, for example, the temperature changes or something stopped moving completely or something dropped, for example. So some kind of physical interactions that are happening in the real world, they will be converted into virtual notifications inside our system, and then you can use it. But mainly, as I mentioned, at this point, we focus on the position because that's from the computing perspective, the most complex problem to have. So then, going through the API, then we cover the locations. So that's the virtual representation of the physical space I mentioned. You can, of course, upload the location, and there is a predefined format that we use for keeping the information about the space. You can get all of them, and of course, you can get a particular one. There are all the details of the endpoints in here, so you can just play with it. You can upload the documentation. Then we have two another sections: assets and asset positions. Assets are the virtual representations of peoples and objects. So we also, apart from virtualizing the physical space, we also need to prepare some kind of virtual avatars, some virtual entities in our cloud, so we can track them over time. In here, you will see that we have also some basic information that you can provide. Of course, you actually, that's something that is also partly our cloud agnostic and technology agnostic. So you can prepare the virtual representation of any object without providing any Estimote specific data. So you don't need to provide a beacon that is, for example, used as a marker, or the phone that we also consider as a marker.
Marcin, could you possibly zoom in on the browser right here? It's just a little bit hard to read. Thank you.
Okay, should be better right now.
Much better.
Yeah, sorry for that. So yeah, so those assets are just representations of the different objects that at some point may be tagged with a particular device. So as I mentioned at this point, we consider phone as a tag, and then we use the indoor location algorithm to calculate the exact position of person or object that is actually having this phone. And then, on the other hand, you can use a beacon, and then the infrastructure actually interacts with that beacon to get the position, and then the position is calculated in the cloud. That's why you can provide, as a device type here, you can provide beacon or the phone. Of course, with beacon, you can also provide a color, and there is also an option, so that's something that is a bit like prepared for the future at this point, but definitely we are going to expand that concept. You can also provide some metadata. So apart from just having the information about the position, you can also keep information about some specific information that you actually need to have for that particular object or the person. The one limitation here is that you can, of course, assign as many, actually, it's like a key value store, so you can assign as many information as possible and as you want. The only limitation is that you won't get any update when those parameters changes at this point. So that's something that is for the future, but at this point you can just keep track of information. So, for example, if you have a coffee machine and you want to keep the information when it was bought and when it was serviced, that's something that you can keep here, and then you can update that information every time you want. And it will be always assigned to that object, so you have a central place to keep the combined information about the object. But on the other hand, when you change that, no one will get the exact notification, so they just need to check again those values and verify if anything changed. Apart from just the basic definition and creation of an asset, you can of course get them and modify if you need. So all the fields may be modified, so you can, for example, use that endpoint to modify the metadata that you prepared. The cool thing about that and making that virtual object a bit separated from the actual hardware is that in that setup, it's extremely easy to actually manage the infrastructure, because in a very simple way, you can, for example, if there is some kind of failure or let's say the beacon was stolen, for example, or just detached somehow, you can very, very, very easily just replace that device with another one, or even with a separate phone or something. And then we still keep track of the same object. So only the hardware layer was replaced, but the virtual representation does not change, and we just continue tracking that device with this new hardware. So if any accident happens, then it's super easy for you to just get out of it, just replace the beacon. They're quite cheap right now, or even replace that with completely different technology. You can at some point even use the manual way of providing the position, for example. So we envision also some kind of use cases where the exact positioning is not required in some parts, for example. So you can still use the system and just provide the position, like the room, for example, that you keep the object in manually through some kind of app or some cloud dashboards, doesn't matter. The API is very generic and it's very flexible. Yeah, so that's the assets, and of course the last section is asset positions. So in here we just give you an API to get and provide the position of particular objects in the space. So what I want to do right now is that we, as an example of using the entire infrastructure, we have a very simple UI here. That's half of our office here in Krakow. It's already mapped, so as you can see, we have a bunch of beacons deployed in the space. They are marking different pieces of our space. It's not that detailed yet, so that's just treated as a demo for now. Of course, it may be much more detailed, but definitely, like the shape was actually created with that auto mapping mechanism we provide. In here, they are not drawn, but there are some pillars that we have in the middle of the office. And there is one image, actually, sorry for that. I wasn't able to provide a proper graphic before the presentation, but that's the visual asset I created for this, as a purpose of this presentation. And that represents actually me. So that the question mark is me on the map. And what we're going to do right now, we are going to, actually it will be extremely hard to just show you the exact in your location remotely or give you an asset tracking understanding remotely. I will just use the API for now to just show you how it works. I will zoom out a bit right now. So we'll try to manually provide some kind of position update here. And you will see that this UI is actually using the WebSocket implementation to update the position on the map. So any change that I will perform using our API will be automatically reflected on the map. So what we need to do first, we need to authorize in that API. The only thing actually you need to do, you are using the regular Estimote cloud account. So maybe I will quickly show you how it works. So there is a cloud Estimote.com, and that's the basic dashboard that we've been providing for a very long time. And apart from the list of the beacons and other things like mirables or mirrors, you have also the apps section. And in that apps section, you can see that there are the actual apps that authorize you and your mobile applications or web applications to interact with our infrastructure. So the only thing you need to do is actually to copy paste that to our API implementation. I will quickly refresh the website maybe just to verify if I wasn't automatically logged out. Yeah, actually I was. So I will do quickly that, and that's something that you will need to do at the very beginning of the hackathon when we are there. So yeah, I just copy app ID and app token here. Oh, sorry. I accidentally cloused the window, so it's asset tracking.com/docs.
And that's cloud.estimote.com?
Exactly, okay. Exactly, cloud.estimote.com. And in here, we just go to that authorize. Unfortunately, I need to replace that, so maybe I'll just move that's the zoom that is actually showing up. So, okay, so I will go here. Bam. I will provide the username and the password and authorize, and that's done. So right now I'm able to use that API easily. So what should happen right now is that when I provide the new position of me, so I created the virtual representation of me before the meeting. And when you, for example, go to assets, so you can get all the assets that we have in the system, you can try it out. I will maybe make the screen bigger a bit. I will remove all the predefined identifiers, and I will try to execute the code. So as you can see, there is a virtual representation of me. So there is only one item and on one page that is actually describing me. So there is Marcin Klimek, that's the name actually I added as a metadata, and I'm represented by phone. So that's something that is showing that probably I will use the indoor location mechanism. And that's my device identifier. So that's the, let's say, the hard-coded particular device identifier that I'm going to use. I just made it as a Marcin Klimek to simplify the demo. And what I want to do right now is I want to update my position. So last seen position was here. So it was probably like 30 in the middle of this distance, so it's 36, so it was like 17 probably, and here it was like probably like 11 or something. So right now I will try to close this particular endpoint, and we will go to those asset positions. And in here, as you can see, we have a post version, so you can just send the exact position of person or object in space. So let's try to do that. I will try to actually squeeze that a bit so you can see the map. Yeah, that's a bit challenging on the smaller screen. Okay, and as you can see, I will just try it out. And what I need to do is actually the default like, template version. I will just remove the second object that should be updated. I will replace the identifier with me. It's still the phone, orientation doesn't matter at this point. We need to get the timestamp, so it would be the best to actually get the current one, so I just use some basic web app to just get that. We will replace the timestamp with the current one. And also we will make a positions like 10, maybe 10. And right now, what will happen is that when I update this position, the map should update as well. So execute that. And in a second, let me quickly check if that was fine. Okay, so there was a success. I think I need to refresh that map as well. Yeah, so the position change, sorry, probably it wasn't updating because I opened that a bit earlier. So let's try to do that again. Let's try to do like X. Execute. Something with the socket I think is failing here. Was it success or sorry, there is something I think I used. Let's try to do that again. Okay, so the previous version worked. Come on. I think there is something with that. Let me just maybe quickly sign out. Let's sign in again. Okay, cancel. Perfect. Always Murphy works in that situations. Okay, so let's get the current timestamp again. I think it's, yeah, let me quickly refresh that. Yeah, I think we just provided the right one. Okay. Okay, it's updated right now. So the phone, Marcin 11. Everything should be fine. Phone. One thing actually I just failed with is the location identifier. So sorry for that, and that's probably something that was the reason that it wasn't working. So every single location, so you can have multiple locations, and every single location is actually having its own identifier, and that's something that I forgot to update. So sorry for that. We will try out the location fetching. And as you can see, there is a different identifier that is responsible for this location. So what we did before was actually we updated the location of an object in like another location, and the one that is mentioned in the example. So I forgot to actually mention that.
So to clarify, so when you say location, that would be the map or the room. And
yes.
So the position is the actual where the device is located inside that location.
Yes, exactly. So we think, like if you are thinking about the office, for example, in here we have 3 floors. So we consider each floor as a separate location that is in total like making our office. And that's how we actually try to set up. So we are not trying to make a single location that is covering entire office, but we are more splitting that into levels, for example, in our office. So
okay, that makes sense.
A separate location. That's why we actually, that's something that shouldn't be an issue when you have an automatic system. That's only the matter of actually this demo. Because when object is, so we are moving inside the space. the proper location will be picked based on beacons. So there is no manual process here. When I move with my phone in like on the first floor, let's say, I will be like my phone will be reporting the position in the first floor location. But then when I move to the second floor, it will be automatically switching to the second location based on the beacons that are around.
Got it.
So on the daily basis, when we work with the fully automatic system, that's not no issue. It's just me forgetting about updating the identifier. Okay, so let's try to do it again. Let's provide the current timestamp. Right now, the current position is calculated for the last 5 minutes. Okay, so that's the current timestamp. We updated the position. We have the proper location identifier. We are using the phone, and that's my device ID. I execute that, and as you can see, the avatar moved. I can do it again. So let's do a 14 and 12. Execute. Bam, it moved again. Let's make it 7. Execute. It moved again. So right now, that's exactly how it works. So when you properly provide the location identifier, the object is in, and then the current timestamp, you can see that I'm just like resending the same timestamp, so it will be replaced in the cloud. But of course, I can increment that in time, and then you can even replay the history of the assets in that space if you want. But that's something that you can, as I mentioned, right now to do customly. So that will be probably part of the task on the hackathon. I can maybe do it again like 11. Yeah, and it moved again. So as you can see, it's actually super easy. And from technical perspective, what is required, if you are working with our indoor location SDK, you just need to use the few lines I mentioned before. So actually this code here, maybe I will make it a bit bigger. You just need to use that code here, and then those updates for particular locations that will be detected automatically, it will be sent in the background. So the only thing you need to do is actually to consume the new position updates using the WebSocket or the REST API. Or if you want to do any other way of updating the position, so for example, you want to use that UWB technology, then what is required is just picking the distance and sending the distance to the cloud. So the position can be calculated, and then you will get that update anyway using the same source point, so the API where the WebSocket or the REST API that provides the new positions. And then, as I mentioned, you can very easily create this kind of experience when you have the moving avatars inside the office that you can see, you can interact with. You can even message them when you enter the particular zone. For example, right now, what we are using as some testing software in our office is a very simple software that is just showing position of our employees, so actually members of our team inside the office. It's not extremely big office, so we have 1,000 square meters right now in here, so that's the one half of the office, and we have the second half. But it's still sometimes challenging just to run around and just search for people. That's why we decided to just build very simple software that will just let us see where people are at the particular point of time. In special cases, the current one. Yeah, so that's definitely something that we are trying to even test and battle test in our office. But I hope it will be quite exciting for you to actually play with during the hackathon and see how it works in practice and build some amazing solutions based on that. Yeah, so actually I hope I didn't take too much time because I think we are a bit late. So that was the basic demo. Again, sorry for not providing this location, but I hope it will just give you the general understanding of the software we have, what can be used, how can be used that, and I hope I just inspired you a bit before the hackathon, so you can think about some specific use cases that you can implement for small business and create them during the hackathon.
Yeah, so there's a couple more questions that came in, and I actually want to just clarify. If I remember correctly, so you just showed us the location, right? Yes. But don't the Estimote beacons have a bunch of other things they can do, like temperature and elevation and sound? Like what's actually the list of possibilities that are available?
Of course, yes. So definitely our beacons are actually in here mainly used for location building in that demo, but in general, they provide a quite wide bunch of information, and they can provide that over the air. So all of the sensor information that are available, they are broadcasted in the telemetry packet, and they can be easily picked by any like gateway or phone that is capable of listening for Bluetooth packets. We actually aggregate some of them in our cloud as well. So the basic cloud, the Estimote cloud here. So you can, when you go to the details of the beacons, I'm not sure we are using those here, but when the telemetry is actually enabled, you can see, for example, here that we provide information about the temperature and the light level here. So you have the exact readings of those sensors in our cloud, and they can also be automatically uploaded to the cloud. So looking at the range of sensors we have, there is definitely accelerometer that you can use. There is temperature sensor. There is a light sensor. In some versions, because also that's quite important to mention that we do not provide only one version of the beacon. We have like a few beacons that are available in our offering, and if you go to, maybe I can quickly do that, estimote.com, you will see that like looking at the different setups you can build, we actually, by beacons section, we provided different sets of beacons. So we have proximity beacons that are mainly dedicated to the proximity use cases that were covered last year. So providing a contextual information on the spot. We have also like the location set, so location beacons that are a bit more bulky, so they're a bit bigger, but they have that UWB chip on board in that variation, so you can use them to actually build the location and just use them as a markers on the walls. So that's their main purpose. There are also stickers, and stickers are the beacons that are created in a very, very small form factor. So they're like, I think the smallest one is the size of the fingernail. So it's very small. Yeah, they are intended to be sticked to some objects, but the limitation here is first because of the size, actually the time that is living on a battery, and depending on the different settings is about like 6 to 12 months. Comparing to the location or proximity beacons that are actually living on a single battery for 3 to 5 years. So that's the difference. And we also provide something we call the video beacon. That's the device that is actually stick to that's actually of this device. So you can see the very nice comparison of all the devices on our website. And the video beacon is the device that you can just attach to the screen. And there is a Chromium browser actually running. So it's something like a computer actually that is running based on browser like Chrome OS, let's say, but in our variation, that you can actually use to display the contextual context. So this particular video beacon is just like, it's actually capable of listening of beacons around. So you can, for example, play with the beacons, and we had a very nice demo of for example, the shoe showroom, where you've been moving different shoes and the contextual information about particular moved shoe was displayed on the screen. And on the other hand, the device is also capable of communicating with the phones. So you can just, with the custom application that is running on the phone, you can come closer to the screen, and then the mirror will automatically detect presence of the phone with the app, and will communicate with it to just display more contextual information just for you. So that's additional possibilities behind this video beacon.
Got it. And you're going to bring all these beacons, all 5 of these buckets of them for the hackers. That's great. That's great. That's great. There was a couple other questions that kind of came in here. One's really you're really related to some of the use cases. Like, could you have some ideas how you use these beacons in a small business store? Like, how would a small business owner possibly use these?
Yeah.
And then, do you know any businesses that are currently doing some asset tracking?
Mm-hmm. So so that's actually that strongly depends on the use case, as you mentioned, and there are very, very different markets that are trying to use that technology. So we've been actually talking to many of them during the past few months, because actually the exact asset tracking efforts, so just trying to talk to clients and verify, what kind of use cases are there. We spent actually the last few months on that purely. And that was quite interesting set of findings. So definitely there are different ways of asset tracking that you can think of. And one quite important thing to understand is that there is a slight difference between asset tracking and inventory tracking. So if you think about the huge warehouses or stores, they are keeping a lot of like inventory that they are just distribute. So they do not particularly own that inventory. They just get it at some point and then distribute it at another point, right? And that's something that is called inventory tracking. Asset tracking, on the other hand, is just tracking of devices that are owned by the company. So you can think about, let's say,
I think our video froze up here. Let's see if it recovers.
to keep track of them.
Marcin, I think the video locked up for a split second there, so I'm not sure the example you were giving, but you started to talk about, I think you're about to give an example of asset tracking.
Yeah, exactly. So asset tracking is actually something that is behind tracking objects that are owned by the company. That's the main point. So if you think about the software house, probably that's quite close to our participants, the software house can, for example, own some computers, some projectors that they do not exactly distribute. They are just having that for a long time at the office, and they just want to keep track of them. So they want to know where they are or what's the condition they are in, and so forth. So that's something that we call asset tracking. And definitely, I think, even during Hackathon and looking at the small business space, definitely we should focus on asset tracking at that point, just discussing various use cases there. And honestly, I've been seeing a lot of different use cases, talking to clients, because just mentioning, I was also doing some product, apart from product development, I was also doing some customer research during recent times. And there have been like cases where, for example, people were exactly trying to track things at the office. So even in the small company, like maybe 20 people, but having a bit bigger space, they want to track exactly people inside the office, sometimes conference rooms, if they are, for example, renting some. So there are some shared spaces, for example, that companies are located in, and just want to know which space is available or not. Then tracking computers, phones, and so on. On the other hand, we, for example, talk to the winery. So they are having a lot of equipment on board that they just need to keep a track on. And they are also, that's a matter of actually that's you need to think about the small companies, that they are not always small in terms of the people. Because there is a difference between the venue size that is required for the business and the amount of people that are hired, right? Mainly when you think about a small business, you think in terms of amount of people that works there. And that's the basic definition. But sometimes the companies, of course, when you just live in IT, of course, that's quite obvious. You mainly see the work environment as an office. But there's a lot of companies that are fairly small in terms of number of people, but they need to have a big venue to actually, perform their operations. You can think about another example is a cinema studio, for example. So the companies that are making videos, there is not that many people actually required to perform the operations. They are quite small. So it may be like 40, 50 people, for example, but the space they need to actually have the all scenes prepared, it's much bigger. So for example, in that space, they need to keep track of all the accessories or all the objects that they are actually trying to make a movie of, or the camera equipment that they keep. So as I mentioned, in that setups, the space is much bigger. And I think that's also another key to looking for the setup that may require this kind of technology, where you have not that many people, but you need a big space to operate. So the winery was another example. We've been talking a lot to to stores or shops, actually, that they've been trying to figure out, even the smaller ones, they've been trying to figure out what kind of items are you, like the interest is behind. So for example, if you have a showroom, let's say, and there is a bunch of objects that you try to sell, you can easily use our technology to get a better understanding, for example, what kind of objects are used the most. So if you go to the shop and you, for example, take a shoe and just play with it, we can easily pick up the accelerometer data and just collect that information in the cloud. So you can like get an understanding that, okay, that shoe was moved much more than the other shoes. So probably that's the product that we should promote more, right, in the physical space. So probably some dedicated shelf or something may be required. So it's more shifting into the analytics, maybe, but still that's the technology, as I mentioned, but we are not providing the exact solutions for the problems. We provide a platform that can be used to build that solution. So that's another example that you can think of.
Got it. So I mean, really, I mean, the way I see it is you have these beacons, right? And they can tell location. They can sense a bunch of things in the environment. Okay, so now, and that's really the point of the hackathon, right? Is, okay, now what? Right? Like because, you know, in a way, I mean, I want to throw the buzzword out, like Internet of Things, right? But but this technology wasn't available to small businesses 5 years ago, and now it's available today. So what problems do small businesses have that maybe one of these devices could be applied to, right? And it could be a small thing. Like it could be just it's mounted next to the ice cream freezer, and all it's going to do is detect a temperature change, which means maybe on accident when they're mopping the freezer and for the ice cream got unplugged, right? Exactly. And so maybe that small business owner, you know, they won't know it till the morning, and they've just lost $4,000 in inventory. But if the beacon can alert them that there's a temperature change, they could go back down to the ice cream shop, replug in the freezer, and save all their inventory. So I think it's really limited by the developers' imaginations, right? Exactly. Where this is going to really tie back in. And then the interesting thing is when you start thinking about how does this tie back to some of the other APIs that are coming, right? Because we have Nexmo coming in. Nexmo is really like communication, so text, voice, that type of stuff. So the beacon could detect a change and then kick off through the Nexmo API a text message alert to the business owner. Right. And then, and I have not really learned a ton about Clarify, but Clarify, they use some images. So they do some image logic processing. So you could combine that, right? If they have some sort of, you don't have any camera AI in these, but if they have a camera and that's taking a photo and doing some identification based off of that, plus with all the things you're sensing, you know, you're starting to get a complete picture, and the solutions really starts to pile on that's available.
Exactly. And I think, you know, the one interesting shift that honestly I would like to also see and like shift in terms of thinking about this technology is that I think, you know, especially last year and a few last years, we've been mainly thinking about the beacons in terms of the mobile phones. So it was always a pair. You actually, the beacon does not have any internet connectivity, and we know that. And there was always requirement of having that phone and being in range of that beacon to actually detect some kind of actions. Right now, what we see on the market and what we're also trying to address in our company, starting with that video beacon, is that we are actually trying to build the infrastructure that is actually having the internet connectivity, direct internet connectivity. So you actually do not need to be on spot to get some kind of notifications, right? And then you can easily integrate a Twilio or something just to get a text message or anything else if something happens. So with a video beacon that is actually having the Wi-Fi connectivity in that particular terms, you can just have your own venue, just, you know, you can just plug it there, display some kind of content if you want. But on the other hand, the beacon will also, the newer beacon will also collect all the data of the sensors of the other beacons that are in that venue and send that to the cloud. And then it's just your thing to actually, you know, come up with an idea what kind of action may be taken if, for example, some kind of parameters change, right? So we are a bit moving, like thinking about the beacons. We are slightly moving from just thinking about the mobile phone all the time. That was always problematic because, you know, from actually every vendor perspective, the main problem is that Apple or Google or any other like hardware or software providers, they are not not giving that much steam into like working with the Bluetooth devices. So they more try to optimize the battery at this point, and we as a company do not have any control over the Android or iOS, for example, implementation. So we even doing some custom work with indoor location mechanism. We came up, for example, with Estimote monitoring. That's something that you can also use during the hackathon, and that's the library that is giving you much better experience behind enter and exit events with the beacons. And that's actually working like 40% better than the basic iBeacon implementation. Because we just wanted to show that if you invest on the system level into this kind of solution and you just put the proper math behind calculating those events, it may be much better. But unfortunately, like we can prepare these kind of things, but we do not have any leverage to actually push Apple or Google to implement them. So from that perspective, like we are a bit dependent on that. And that's why I think that the shift is happening, because we see that Apple and Google are not that deep behind these kind of projects, but on the other hand, there is a huge potential behind the technology. So we probably can build like a separate ecosystem that is not dependent on the mobile devices, that can deliver extremely big value to the customers.
Got it. Cool. So there's two more questions that are kind of coming in. One is, I think you've kind of already answered this by really, you've clearly said like, we're just a platform, right? You don't actually make the software for the end user, but the question was, can the software be used by an ordinary shop owner, or is it really just targeted at a programmer and developer?
What do you mean? Can you repeat?
Yeah. So can just a small business owner just go buy these beacons and just start using them, or do they really need a developer or a programmer to go and create something that takes advantage of these beacons?
Yes, so definitely, like what we see and what we're trying to address right now is that the entry point, the technology was quite high. And definitely we see that as a problem. Of course, we work closely with the developer community, but definitely developer was required actually to build a solution. So there was actually maybe working directly with Estimote, like was working that way. But we have a lot of third-party companies that are just taking our stack and then they are building some particular solutions on top of our stack, and then they are actually selling the software to the companies. So that's actually the model that we are trying to work in, where because it's extremely hard if you think about the company of our size, like less than 100 people at this point. It's extremely hard to actually focus on any use case, because it's like the number of possible applications of the technology is extremely wide.
Yep.
Probably if you want to address one, you probably should just set up the proper company behind that.
And that's why there's the need for developers, right, to build these solutions, because you can't build everything on your own. And so that kind of leads to this next question. It's very specific, but I think you may have just kind of answered it. It's a hypothetical. A dairy farm in London wants to know why they should invest in Estimote beacons. They already have QuickBooks, but they want real-time tracking when the delivery vehicles are out delivering their products to their customers.
Mm-hmm. So they want to deliver products to their customers, and what they're actually using right now. Can you repeat that?
It doesn't have that. What I can do is the person asked the question, Sanidade, I'm gonna flip your microphone and allow you to talk. So let me flip that over here.
Much better. Get a better understanding of the question.
Sanyanade, I'm trying to unmute you here. I don't know if you have a microphone or not. All right, it doesn't look like that person has their the ability to ask a question on the
chat.
Oh yeah, no microphone at all. Okay, so just in the chat, but I think it's it's a very specific use case, and maybe they want to track the locations of the delivery trucks delivering the milk.
Mm-hmm.
Can Estimote beacons work, to track a vehicle traveling hundreds of miles, or are these for actually like more physical spaces that are static?
Of course, that's a very, very good question. So actually, there is the set of actually technologies that are right now mainly used for tracking fleet of cars or like bigger objects that are actually moving around the Earth, more or less. Of course, there are some like dedicated hardware pieces that are, for example, using GPS, and probably that would be the first thought. But okay, we can just use GPS just to track the location of the particular car or anything else with GPS, and there are dedicated GPS trackers that are just doing that. On the other hand, you can, they are quite expensive, so probably another thing you can do, and that's actually the setup that we've been working with like another company, one of our clients, to achieve. So they actually wanted to put beacons inside the trucks, and then they've been using smartphones of the drivers. Actually, that company had, the set of like the group of drivers that they've been distributed the app. Doing some other things, but also like it was possible to integrate some additional piece of software, some kind of library into that application to extend the functionality. And they've been building a model where you have beacon in each truck, and then your phone detects that the driver is inside the car or outside the car, and based on that information, the GPS position was just collected from the phone, but only when the driver was actually moving and it was nearby the beacon. So in that setup, it is actually possible to think about some kind of systems that are using beacons actually to get this kind of information. And in that setups, the mobile phone was a requirement. The GPS signal was taken from the phone, not from the beacon or any other tracker. And then the beacon was actually mainly providing the context and the information that, okay, you are inside the car and you are moving. That was the main sort of information that was taken from the beacon. And maybe one addition is that, of course, you can also know from, I think Google Maps also provides you this kind of information that you are moving inside the car or you are walking or something. But the important thing in that particular deployment was that they also wanted to know the exact car you are in. Because, the generic information from the phone is that you are just driving a car, but you don't know which one. So that was the point of having the beacon inside the car.
Got it. So that additional layer of communication, that makes sense. Got it. So that's exciting. I mean, I think it's a really unlimited the amount of solutions that could be possibly created. I think especially when you start combining with other APIs, right? Like it's not.
Yeah, definitely. We do not see ourselves as just a single company that is addressing all the needs. Definitely, I think the power is just behind integrating different pieces together. And that's something, some kind of creative process that brings to amazing solutions.
Got it. And so are you going to actually be at the hackathon or somebody else from your team?
Absolutely. Yeah. So we are coming together with Piotr that was there last year.
Okay.
Together on Friday. So if you want to have even before meeting with us, we will be available on Friday evening. And then we are there entire weekend. So we'll help you hack. We'll give you all the hints. We'll probably even at some point pair with you, just helping implement the amazing solutions.
Great. And then do you know what prize you're giving out?
Honestly, I'm not aware about that at this point. Okay. So yeah, but definitely in most cases when we go to hackathons, we have something to for the participants, some kind of prizes. So probably that will be something that will be announced a bit later.
10 million British pounds. Is that correct?
Not sure if that high, but yeah, something definitely valuable.
Awesome. This is looking forward to it. I'm glad you're participating, you're showing up with us, and you're bringing all these beacons because I think there's just a lot. I think you're opening the door to tons of problems that nobody could solve before without these beacons. So yeah. I'm really looking forward to it. And with that said, there's no more questions. Just a reminder to everybody, if you're watching this after the fact, go to the events page to see the who else is coming up next. It's developer.intuit.com/hub/events. And hopefully tune in for the next one. And next week we have clarified.ai. Awesome.
Awesome.
Thanks, Marcin.
Yeah, thank you very much. Have a nice day, actually.
Okay.
And you guys all have a great day. And see you in London.
Awesome. See you in a bit. Bye.
Thank you. Bye.